Let's take a look at 7-1 try it, number 4. It says the length of a hypotenuse in a 45, 45, 90 triangle is 5 times the square root of 2. What are the sine and secant ratios for a 45-degree angle? Okay, so again, you can do this using the Pythagorean theorem. In fact, in the notes that I'm publishing in Focus, I went ahead, I did it that way. But again, you can use this simple way. Remember, we have a 45, 45, 90-degree triangle. That's a special triangle. And as we learned before, here's our ratios. So if my hypotenuse is 5 times the square root of 2, well, that means x equals 5. Quick and easy. My side lengths are x, so that means my side lengths here are both 5. Okay, so now sine of theta is opposite over hypotenuse. Okay, so we're looking at either one of these angles. They're both the same. It doesn't matter which one. So opposite would be 5 over 5 times the square root of 2. Okay, I should have left more room here. Remember, these 5s, we can reduce this out, which leaves me with 1 over the square root of 2. Okay, we don't ever want to leave a radical in the denominator. I'm just going to scoot this down over here. We're going to do what's called rationalizing the denominator. So if you see a radical in the denominator, just multiply numerator and denominator by the square root 2 over the square root of 2. Remember, this is 1. Any number over itself is 1, so we're not changing the value at all. 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2. Remember, when you do that, you undo the radical. Gives you 2. So this is my final answer. Sine of theta is the square root 2 over 2. We are going to be using that value very frequently. Now, secant of theta. Secant is the reciprocal ratio for cosine. Cosine is adjacent over hypotenuse. So that means secant is hypotenuse over adjacent, which means we have 5 over the square root of 2 all over 5. And again, here your 5s are going to cancel out. Secant of theta equals the square root of 2.